function f of x is approximated near x equals 4 by the second degree Taylor polynomial, which is 84 minus 44x plus 6x squared. I made this graph so that you can visually see what we're doing. So in the black, this black function right here, that's our second degree Taylor polynomial. That's this equation or this function right here. Because the question did not give us any information about f of x, and I really wanted you to see what was going on, so I made up an f of x that works for this situation so you can understand what we're doing. And so the f of x that I created is this in purple here. Now the question says that this Taylor polynomial, degree 2, when you're looking at values of x close to 4, this Taylor polynomial will give us a good estimate of the function. So we're going to use the black function to estimate the purple function. But we can only do that for x's that are close to 4, because you can see that the function and then the Taylor polynomial are close together in this area. So it should give us a decent approximation. But if we go outside that area around x equals 4, we're going to start getting values that are far apart, and it's not going to be a good approximation. So just make sure that you understand that it's important to stay around x is equal to 4. So what we need to do is we're going to find the value of the function at 4, the value of the derivative of the function at 4, and then the value of the second derivative evaluated at 4. Now, because we're plugging in values that are close to, in this case, equal to 4, I can use this second degree Taylor polynomial to give us an estimate for that function. So when I plug in 4, I'm going to get out 4 here. Now, if I want to estimate the derivative of the function at 4, since we're using this as our estimate, I'm going to take the derivative of 84 minus 44x plus 6x squared. So that's going to give us a derivative of negative 44 plus 12x, and then we need to evaluate it at x equals 4, and that's going to give me a value of 4. Last one, we need to find the approximation of the second derivative at 4. So we're going to find the second derivative of the Taylor polynomial and evaluate it at 4. So I'm looking at the first derivative, and I take the derivative of minus 44 plus 12x to get our second derivative. And that leaves us with just a constant, which is 12. So when I evaluate that at x equals 4, I'm just going to get the value 12. So these Taylor polynomials can help us estimate some functions in a certain area of a value of x. And we want to make sure that we stay in that area if we're making that approximation.